Assalamualaikum, my name is Nur Ilani binti Ishaq with student ID TM21015. So today I will explain introduction for our project. Welcome to our project where we have chosen the crude oil distillation process, also known as the fractionation. This method kickstarts the refining process by breaking down crude oil into distinct fractions or cuts through distillation in atmospheric distillation column. These cuts with specific boiling point range are classified into the gas, light distillers, medium distillers, gas oil, and a residuum based on the decreasing volatility. Now, let's dive into atmospheric distillation tower. The dissolved crude feedstock undergoes initial preheating, entering a direct fired crude charge heater just above the column bottoms. Here, pressure are slightly above atmospheric and temperature range about 950 to 700 Fahrenheit. It's critical to avoid exceeding this pressure to prevent undesirable thermal cracking. As the feedstock ascends, almost all the heaviest fraction into the vapor. The ascending hot vapor cools through the natural convection at the bottom. Heavy fuel or asphalt residue is collected. Major products like lubricating oil, heating oil, kerosene, gasoline, and incandescent gas are captured at the progressively higher point on the tower. While the fractioning tower is standing around 120 feet tall, it is a steel cylinder with horizontal trays inside. These trays separate and collect various liquid cuts. Vapors enter each tray, bubbling through the liquids, leading to the condensation at the trays. This temperature, an overflow pipe drains condensed liquids back to the tray below where higher temperatures cause re-evaporations. In essence, our project employs this indirect crude oil distillation process to refine oil into valuable products efficiently and precisely.
For 3D plan layout, in the crude oil distillation process, we use one column which serves as the main unit for the separation of crude oil into distinct fractions. As crude oil is heated, fraction with lower boiling point vaporize and rise through the column. The condenser positioned at the top of the column cool the vaporized fractions. Next, we use one heat exchanger. The heat exchanger plays a pivotal role in the crude oil distillation process, primarily serving the crusher function of providing heat for the evaporation of liquid feed in the reboiler. After that, two pumps to assume a fundamental role in intricate machinery of a crude oil distillation plant, undertaking diverse functions essential for the smooth operation for entire process. In a crude oil distillation plant, the piping system and pipes serve as essential conduct for the seamless transfer of fluid throughout the processing unit. Pipes play a crucial role in connecting various components.
Assalamualaikum warahmatullahi wabarakatuh. So I will continue on the calculation the length of the spool that include the gasket, flange, fitting and length of the root cap for bevel bolt welding. So the table that I refer is dimension of class 300 flange and also the bolt welding pipe fitting dimension standard ANSI for B16.9. So the pipe 1, it includes the height of the flange according to class 300, which is 84 mm, the takeoff of length of the equity according to class 40, which is 105 mm, and the length of the 90 elbow long radius that according to class 40 is about 152 mm, and we assume the root gap for standard which is one joint equal to 4 mm. So on the pipe 1, it has two joints, so the total root gap at the pipe 1 is equal to 8 mm, and the width of gasket according to class 300 is about 3.3 mm. So the total length of pipe 1 is 766.9 mm. So for the pipe 2, the length of the 90 elbow long radius according to class 40 is equal to 152, It also involves the equality that according to class 40, which is 105 millimeter, and also we assume the root gap 8 mm because it has two joints on it. And for the pipe 3, for the length of pipe 2 is about 1995.5 mm. So proceed with pipe 3. It involves the elbow, equality, flange, also the gasket, and the root gap same, which is 8 mm because it has two joints on pipe 3. So the total length of pipe 3 is equal to 408.1 mm. So the last pipe, which is pipe 4, that include the flange, gasket, equality, and also the root gap 8 mm. And the total length for pipe 4 is about 1487.2 mm. So the total length for the spool include the all pipes 1, 2, 3 and 4 is about 3657.7 mm.
Assalamualaikum. Hi everyone. My name is Zulaika. Today we're gonna dive into the wall piping spool fabrication. This process involves several key steps. Firstly, review drawings and specifications. Our journey begins with a careful review of piping drawing and specification. This helps us understand the requirement, dimension, material and welding procedures needed for the job. Second, material inspection. The pipe fitting and flanges, ensuring they meet quality standard is crucial for a study spool. Third, each component gets a mark and we plan the production sequence accordingly. It's all a precision and organization. Fourth is cutting pipes. We then cut the pipes to the required lengths, ensuring precise measurements and clean edges for a seamless fit. Fifth, beveling comes next, shaping the pipe ends to the specified angle and length. This step ensures robust joints and better welds. And sixth, assembling pipes, fittings and flanges according to the drawings is our fit-up step. Tack welds may be used to hold everything in place. Now the magic happens. We weld the joints, use different techniques. Make sure to follow procedure. Non-destructive examination ensure weld integrity. Then post-weld, we clean up, remove slag and spatter with grinder or wire pusher. Internal weld bits are smooth if necessary. And to protect against corrosion and enhance aesthetics, spool get a protective paint or coating following industry standards. Before the grand reveal, a final inspection ensure everything meets project specifications from dimension to material quality. All the paperwork is assembled, inspection reports, welding procedure, and more. Spool are labeled for easy traceability. Finally, our finished spools are carefully packaged and transported to the installation site, complete with proper labeling and documentation. And there you have it, piping spool fabrication in a nutshell. A meticulous process ensuring our pipes are not just pipes. They are well-crafted work at art. Thank you for joining the journey today. Thank you.
So for the conclusion of a piping project is the successful operation of a crude oil distillation plant relies on the coordinated effort of heat exchangers, pumps and a well-designed piping system. The fabrication of piping spools demands precision and attention to detail that involve the multiple steps to ensure the compliance and specification and standard. The proper alignment and leveling throughout the fabrication process can contribute to the reliability and efficiency of the piping system, which is essential for the overall success of the crude oil distillation operation. Thank you.